All right, folks, here we are again. We're going to talk about bark beetles. Once again, you've got all of your species accounts to your bark beetles in your field guide. These are really nice summaries. They have all the information that I want you to really be privy to. Remember, that's, how do I identify it? What sorts of trees does it host in? What sorts of damage does it do? And then what are some management options for controlling them? We're just going to go down the list of the bark beetles that are in your field guide and on your lab sheet. I only have specimen material for 5 out of the 7, I think, that are on there. But we'll take a look at each one of those and give you the kind of quick and dirty on how do you identify what are some of the key points of those species. Let's start with Douglas fir beetle. What's the host? It's in the name, right? Douglas fir beetle. Turns out they can also host in western larch. However, only larch trees that have been recently cut, either through logging operations or blown down in windstorm, are going to are they going to be successful in? In other words, they're capable of being a primary bark beetle in Douglas fir. They're only capable of being a secondary infection bark beetle in larch. The Douglas fir are also usually stressed when they are attacked. So these are a beetle of events that produce lots of stressed trees. So it can be drought, it can be wildfire, it can be wind throw, and wind throw events have been responsible for creating large populations of Douglas fir beetle. All right, the galleries. You can see in the galleries right here that they are vertical egg gallery. Right? They do often have a little bit of a curvature at the bottom. We'll come back to that when we talk about mountain pine beetle, J-shaped a little bit. But one of the interesting things is notice that the larval mines come off of the main egg gallery in sort of an alternating pattern, all right? No other bark beetle has that alternating pattern of larval mines, and that's because several eggs are laid on one side, and then the female switches over to the other side, lays eggs up the other side of the gallery. And it's thought to be a mechanism to reduce competition between the broods. And you can see that when a tree is heavily infected, the broods will start to compete with one another. And these guys were successful here. You can see they mined out there and got to a point where they were able to pupate and exit, and there are exit holes in this piece of bark. So how do you identify Douglas fir bark beetle in specimen material? You're looking for that Douglas fir, characteristic Douglas fir bark, Douglas fir host, and then the vertical egg gallery with the larval mines going off to the side in an alternating fashion. All right, our next bark beetle is called the Fir Engraver Beetle, and the previous one was in Douglas fir, this one just fir. So what do you think the hosts are going to be? Turns out all the true firs, genus Abies. So the distinctive thing about this one, and this is one you're never going to miss because it's the only one that does a horizontal egg gallery of the ones that we study. So we're going to study a number of these beetles. Only one of them has this horizontal egg gallery. Now there are other species of beetles that create horizontal egg galleries. For instance, the ash bark beetle, Lepuricynus, creates a horizontal gallery, but that's in ash trees, and we don't have that one on our required list. So horizontal galleries for the egg galleries, and then find a good larval mine, set of larval mines here. The larval mines extending upward or downward from the egg gallery. All right. You can see that very well in the bark as well. So this is a piece of bark, and there's the horizontal egg galleries and the larval mines that go vertically or, vertically either up or down away from the larval mine. Now, the Fir Engraver Beetle, and it again covers this well in your text, is largely a secondary bark beetle, and it's very commonly associated with root diseases. So when we see trees that are heavily stressed from root disease, we often get outbreaks of Fir Engraver Beetle. Incidentally, The term engraver beetle is used because of the fairly deep etching into the wood. Now, the Douglas fir beetle leaves no etching in the wood at all. All of the activity is confined to the cambium and the phloem. But in the engraver beetles, they actually etch into the wood. All right, so Fir Engraver Beetle, Scolitis ventralis. I guess I forgot to give the scientific name of the Douglas fir beetle, and that's Dendroctonus pseudotsugae. And so pseudotsugae refers to the host species of Douglas fir. Dendroctonus refers to dendro from tree and octonus to kill. And so it basically translates as tree killer. So you'll notice on your lab sheet that many of the beetles we're studying are in the genus Dendroctonus. The next one is also another engraver beetle in a different genus than the fir engraver beetle, and that is the pine engraver beetle. And the pine engraver beetle is got a, again, very distinctive gallery. And you can see that these egg galleries themselves are usually like an inverted Y shape or an X shape. We don't have an X-shaped one on here. Here's some great examples of the X-shaped ones. So you can see engraver comes from the fact that they are etched fairly deeply into the wood. And this little pocket right there is referred to as the nuptial chamber, and that's where mating takes place. Mating occurs in the nuptial chamber with as many as up to, the literature says, 5 to 7 females. And each female then strikes off in a direction to create an egg gallery. And then the eggs are laid, and you can see that then the larvae mine outward from there and feed underneath the, on the phloem and the cambium and create damage to the trees. Ips pinei, pine engraver beetle, is also largely a secondary bark beetle. They are found very commonly in the tops of stressed trees. So this is considered to be a beetle most common of tree tops. And then as those tops are infected, we can often see further infection of other bark beetles in other parts of the trees. When logs have been burned, trees have been killed by fire or cut, ips can host in any part of the tree, so it's not limited to the tops. You can see them in any part. And this is just a piece of firewood from the Bend district that had a really nice stage of ips development when it was cut. And you can see that they're very dark layer here, stained, and then the engraving through there. In older pieces of wood, you'll see something like this. So you can see that this was etched by engraver beetle quite a bit longer ago and was weathered somewhat. So it's not always nice and obvious and fresh, but you get these Y-shaped galleries or X-shaped galleries. And again, if you think about the shape of the gallery being related to how many females were present in the nuptial chamber, a 5 or 7 stranded gallery will have some sort of weird octopus shape to it, but most commonly it's 3 or 4. Host species, pine engraver beetle. Turns out it's the yellow pines, not so much the white pines. Ponderosa and lodgepole here in Central Oregon, and lodgepole pine is probably the most common host, although I see a lot of this in the tops of ponderosa as well. Incidentally, the ips is what we consider a small diameter bark beetle, meaning it is capable of finding enough food to raise a brood in fairly small diameter material. So we often see it in large limbs. That's a place I've found it when pruning has gone on. And arborists have pruned large ponderosa limbs and then just thrown them somewhere and let them sit. Ips will get in those 2 to 3 inch diameter limbs. This next beetle, the mountain pine beetle, is probably our most destructive beetle in terms of the total acres impacted. And I've got some other video links posted for you guys to look at some of the effects of the most recent outbreak of mountain pine beetle. Here's something though about the mountain pine beetle. This one has a bit of a built-in protection measure to prevent killing all of the trees. And we hear a lot of doom and gloom about how mountain pine beetle is going to kill all the lodgepole, and it won't ever do that. Not to say that it's not going to have massive, long-lasting ecosystem and wood product impacts, recreational impacts, etc., wildfire impacts, but the good news is they don't feed successfully on trees smaller than 4 inches in diameter. So Ips pinei was the pine engraver beetle. Now we have the mountain pine beetle, which is back in that genus